looked like this. I'm going to write this up here. X is greater than 7. Do you remember graphing those?
Yes.
Remember graphing those? We draw a number line, and we do either an open or closed circle and draw an arrow. Do you remember those? Okay. We're going to do these now, rather than on just one number line, we're going to do it on the coordinate plane. Okay? We're going to do linear inequalities on the coordinate plane. In linear inequality, it just describes a particular region of the coordinate plane that has a boundary line. Okay? That won't really make a whole lot of sense to you yet, but by the end of this lesson it should. Solutions of an inequality are all the coordinates that make the inequality true. So all the coordinate points that make your inequality true are all solutions of the inequality. Okay, so let's look at an example, and hopefully by the end of the lesson this will make more sense. Okay, so example 1, we have an inequality, y is greater than 2x plus 3. What form does that look like? What form is that in? Imagine if that had an equal sign. What form would that be in?
Y equals mx plus b.
It would be in y equals mx plus b, except for now we have an inequality, right? It still works the exact same way when it comes to graphing. This is still mx plus b. So we still graph exactly the same way. We start with
2.
No, not the 2. That's the slope. We start with b. We start with the number that's without the x, the 3. So we're going to put a point on our y-axis at 3. All right? And then we're going to use our slope to find the rest of the line. Our slope is 2 over 1. What does that mean?
Up to.
Yeah, I rise 2, so I go up 2, right 1. Instead of saying over, let's say left or right, because over, that could be this way, it could be that way, I don't know. So, up 2, right 1. So we go up 2, right 1. And I want you to go ahead and put 3 more points above so that we go all the way up to the top. And then we're going to do all the points on the other direction too. So we can switch directions on our slope and go down and left. So now let's go from 3, let's go down and left. So down 2, left 1. And I want you to fill it all the way up and down the graph. And I do not want you to connect the dots yet, because we have to talk about this before we connect our dots.
It's not equal. It's not equal.
Yeah. Okay. So, you remember, like I mentioned, the open circles, closed circles, correct?
Yeah.
Instead of open and closed circles, we're now going to do instead a dashed or solid line. So I want you to write above the coordinate plane here. If it is greater than or less than, it's going to be a dashed line. All right? If it is greater than or equal to or less than or equal to, it's a solid line. And what we're drawing here is a boundary line. And I'll explain exactly what that boundary line is dividing up in just a minute. But is this one on this equation, or inequality, I'm sorry, is that going to be a solid or a dashed line? It's going to be a dashed line. So rather than connecting the dots in a solid line, I want you to connect them in a dashed line. And what this boundary line does, okay, this line on the coordinate plane divides this coordinate plane up onto one side that has coordinate points that are solutions that would make this inequality true. The other side, those coordinate points won't make it true. So there's one side that's true with the inequality and one side that's false. Our goal is to find out which side is the true side. Which side is the true side? So what you do is you use what's called a test point. Okay, you use what's called a test point. We're going to pick a point on the graph that we can test in our inequality. We're going to do a test point into the inequality y is greater than 2x plus 3. Now, the point has to be on, or not on the line, I'm sorry. You got to pick a point that is not on the line. Okay, so for your test point, you have to pick a point that's not on the line. And let me just tell you a hint here. 0, 0 is a really easy point to test because anytime you do operations with 0, a lot of times you're canceling stuff out because 0 times stuff is 0. 0 times numbers are 0. So 0, 0 is an excellent point to test as long as it's not on your line. If it's on your line, you got to test something else. So we're going to put 0, 0 in for x and y, and we're going to see if we get a true statement. So we're going to get 0 is greater than 2 times 0 plus 3. We're going to see if this is true. 2 times 0 is gone, and you get 1 is greater than 3. I'm sorry, not 1. 0 is greater than 3. Is that a true statement? No. So what that means then, which side is 0, 0 on, top or bottom, above the line or below the line? Below the line. That means if 0, 0 is not a point, it's below the line. None of these below the line are points or solutions. So we want the other side. So that's what our test point does. Our test point checks to see is it on the true side or is it on the false side. In this situation, it's on the false side. None of these coordinate points are solutions, but all of these are. And how we represent that is we just shade in that region. We shade in the region that is true. So all of these coordinate points right over here, all of these. You're going to shade everything above the line because all of these points will make the inequality true. All the points that are on the unshaded side do not make the inequality true. You don't have to get it all the way colored. Just kind of squiggle it in. Okay? So that's the point. That's what you do with the test point. So what this graph is representing is all the points that are solutions to the inequality. Everything in blue over here, if you plug in any coordinate point on this side into this inequality, you will get a true statement. Anything on this side, well, you won't get a true statement. What about on the line? What about coordinate points on the line? Are they solutions or not? Do you think they're solutions? Let's test one. Let's test one and see. Let's pick a point on the line. How about, we'll pick this one, 0, 3. Let's test it and see what we get. If I plug that in up here, 3, 0, 3, I'm going to get 3 is greater than 2 times 0 plus 3. So I'm going to get 3 is greater than 3. Is that true? No. That's why it's a dashed line. That's why it's dashed. If this had an or equal to on it, we'd have had a solid line and it would have been true. So that's why the dashed solid line. The dashed line, all the points on the dashed line are not solutions, but if it was a solid line, they would be. So that's kind of the concept behind these graphs, what they represent. You're shading in all of the coordinate points that are solutions. All right, now let's look at the next example here. The next example is not already in slope-intercept form for us, so we need to get it that way. So we're going to go through and take 3x minus 5y is less than or equal to 10, and we're going to get it into slope-intercept form. I need to get y by itself. What's my first step? Subtract 3x. We can't divide yet. We will soon, but we first have to subtract 3x from both sides because we have to get the negative 5y completely by itself. So that cancels. Bring down the negative 5y, and please bring the negative with it. I know it looks like a minus sign, but it's also a negative to the 5. Negative 5y is less than or equal to. We're going to put the x term first. Negative 3x plus 10. Yeah, well, very good, Nico. Can't get anything past you, huh? Good. Listen. Nico says we have to divide by negative 5. Okay, and what he remembered is that back when we were working with inequalities and we were solving inequalities, anytime we divided by a negative number, what did we have to do to our symbol? We had to flip it around. The same thing still holds true. We cancel that out. We get y is greater than or equal to. Okay, greater than or equal to. Negative 3 over negative 5, that just becomes 3/5 because it's a positive fraction if both the numerator and the denominator have a negative sign. And then 10 divided by negative 5 gives you negative 2. So here's our new inequality. So you cannot forget the rule when you're dealing with inequalities. If you have to divide both sides of the equation by a negative number, then you have to flip that inequality symbol. That's very important that you remember that. Okay? Now we're ready to graph this line. Where do we start with? Negative 2. We put negative 2 on the line. Our slope is 3/5. What direction does that tell us to go? Up 3, right 5. Okay. Up 3, right 5. Up 3, right 5. If I want to go the other direction, I'm going to flip my arrows. I'm going to go down and left instead. So now I'm going to go down 3, left 5. Now, is this going to be a solid or a dashed line? It's going to be solid, yes, because it's or equal to. So that means these solutions on the line are points. They are solutions, and we know that. But now we need to decide, are they the points above it, or are they the points below it that we shade? So that's where we do our test point. Is 0, 0 on the line? No, it's above it, so we can use it. And we might as well because it's the easiest one to use. So I'm going to, up here, I'm going to put in 0, 0. So you get 0 is greater than or equal to 3/5 times 0 minus 2. 3/5 times 0 cancels out. You get 0 is greater than or equal to -2. Is that a true statement? Yes, it is. So if this is a point, a solution, then everything else is a solution above it. So you're going to shade everything above it. All right. So you don't have to color in every single thing. Just shade it. Now that I've showed you the test point method, using the test point, I'm going to show you something that kind of is a little bit easier to look at without having to do a test point. You want to know how to do it? Yes, no? Okay. It's easy. You have to look at the inequality in the slope-intercept form. This is the important part, guys. In order for what I'm about to tell you to work, you have to look at the inequality in slope-intercept form. You can't go back and look at it in that standard form. So I'm going to look at this inequality right here. What is this inequality sign? It's greater than, right? Do you notice that we shaded above the line? We shaded all the points above the line, right? Greater than the line. If this had been a less than, we'd have done below. So on example 1, you could have done the same thing. Because it's y is greater than, so you could shade it. We shaded above the line. That's another way to look at it. But I wanted you to understand what a test point was, so that's why I showed you that too. But if you are going to do it that way, you have to be very careful, and you have to make sure that you're looking at the equation in slope-intercept form. Okay. All right, let's look at the last problem here. It's a word problem. All right, suppose you budget for a party and you can spend no more than $12. That right there, that statement tells you you're going to work with an inequality. Because you can spend no more than $12, which means what? You got to spend less than 12, right? Okay. And we're going to buy peanuts and cashews. We know that peanuts cost $2 a pound. Cashews cost $4 a pound. We need to find 3 possible combinations of peanuts and cashews that you can buy. So here's the things we know. We know we have to spend less than or equal to $12. We know that. We also know how much they cost. But what do we not know? How many what? How many pounds of each we're going to buy. Yeah. So those are our variables. So I'm going to go ahead and say that x, let's say that x equals number of pounds of peanuts, and y is the number of pounds cashews. Okay, so those are our variables x and y. Now we need to write an expression, write an inequality that represents the cost of how much we're spending. How we calculate that cost. If we go to the store and we buy X pounds of peanuts, how are they going to calculate that cost? Huh? Yeah, you're going to multiply it by 2, right? We're going to multiply how many pounds of peanuts you bought by 2, and that will get you the cost of peanuts. You're going to add to that the cost of your cashews. Well, that's 4y. We know that this is how much we spent. What do we know about this in regards to the $12? Does this have to be? This needs to be less than or equal to $12, right? So we're going to do less than or equal to $12. Okay, that's our inequality. Now, we have to get this into slope-intercept form. We need to get y by itself. So we need to do something to this 2x. Subtract 2x from both sides. This cancels. We get 4y is less than or equal to negative 2x plus 12. Because remember, we have to write the x term first. And then we need to get rid of the 4, right? We're dividing by 4. We're dividing by positive numbers, so we don't have to flip our inequality symbol this time. This one just stays the same because we didn't divide by negative. Cancel out the 4's. We get y is less than or equal to. What is 2/4 in fraction? What is that? Negative 1/2. Negative 1/2 x plus 3. So that is the inequality that we are going to graph. So where do we start on our graph? We start at 3. So I'm going to put a point at 3 on our graph. On the y-axis. Slope is negative 1/2. A lot of you guys are still having trouble when it's a negative fraction. For some reason, you guys are having trouble when it's a negative fraction. You tend to make it positive for some reason. So let's talk about that in a minute. Negative 1/2. The negative has to either go with the numerator or the denominator. You pick one that it goes with. We'll put the negative with the 1. Negative 1 over positive 2. What direction does the negative 1 tell us to go? Down 1 and right 2. We could have also put it with the other way. Plus 1, negative 2. That would tell us to go up and left. But will up and left help us? We can't go up and left, so we got to go down and right. So we're going to go down 1, right 2. Is this going to be a solid or a dashed line? Yeah, it's definitely solid. Now, using the method I talked about a while ago, because this is in slope-intercept form, you look at my inequality symbol. It says y is less than or equal to. So which way am I going to shade? Below. But before you start shading, let's talk about it a second. Our problem is dealing with number of pounds of cashews, number of pounds of peanuts. Let me show you where our origin is. Our 0, 0 mark is right here. Okay? Here's my x-axis. Here's my y-axis. All of these points below the line will make the inequality true. All of these things will make the inequality true. That is true. However, you have to look and see if they make sense to the problem. We're talking about number of pounds of cashews and number of pounds of peanuts. Will it make sense for us to be in any of these negative regions? Can we buy negative pounds of peanuts and cashews? We cannot. So where am I going to put them then? Where am I going to put the shading? I'm going to put it right here in this little triangle, right? These are all the values that kind of make sense. All right? These are the values that make sense. I mean, these below in the negative are solutions to the inequality, just not solutions that make sense. So it asked us to find 3 combinations of cashews and peanuts that work. Any coordinate point in this region, the shaded region, will work. Let's talk about all the boundaries, though. This boundary line in blue right here, this y is less than or equal to negative 1/2 x plus 3, this line right here, will solutions on that line work? Yeah, it's a solid line. So any of these solutions will work. Let's talk about our x and y axis. Those are going to work, right? Will those make sense to the problem? What do you think? Let's pick a point on here. How about 2, 0? Could we do 2, 0? Will that work for our problem? Well, 2 is your x value, right? So 2 would represent number of pounds of peanuts, correct? 0 would represent number of pounds of cashews. Can I go in and buy 2 pounds of peanuts and skip the cashews? I can? Is there a specification? Is there a specification in the problem that says I have to buy each one?
Three possible combinations of peanuts and cashews.
Right. Well, is it 2, 0 a combination? Could I buy 2 pounds? I know, but listen, can I buy 2 pounds of peanuts and choose not to buy cashews? Is that okay? All right. Okay. So yes, you can. We could do 2, 0. That could be one solution. We could do what else? Pick something. 2, 2. That would work. How about 1 1/2 and 1 1/2? Will that work? Yeah, that'll work too, because you can buy 1 1/2. So any solution inside this triangle and anything on these boundary lines will actually work. possible combinations. You can pick any 3 in this region. All right. Any questions? All right. Thank you for listening.